Welcome, everybody. We're going to be working on Unit 5 tonight, and we are going to be starting with a lecture material things. Our topics for the evening are summary queries, what they are and how they work, and some new commands that go with them. We'll also talk about SQL functions, most notably what we call aggregate functions, and we'll talk about what that means. But functions are like in a programming language, are pre-built snippets of code that kind of give you capabilities that you don't otherwise have without writing a bunch of other code first. And then we also learn about grouping and summarizing data and what that brings to us in the form of queries and why it's a powerful collection of tools. We're going to start by looking first at what functions are, and we're going to jump over to W3 Schools to do this. And of course, I'm going to try to do this once again in my Brave browser to block all the pop-ups and ads and whatnot. And you can see I have the stuff from last week still in there. That's all right. We'll just drop this in and go. All right. So we're going to start by talking about two very commonly used ones, the min and the max functions. Now, keeping in mind that some of you may have had a coding class already, and some of you may have not, right? So you may be taking databases before you're taking Python or whatever. If you have learned how to code, you will recognize that many programming languages have functions built in either to their math libraries or their standard libraries, the min and the max function. And basically what those do is they look at a collection of values and find the biggest or the smallest one. Now, if I'm looking at a list of numbers on my screen here, and it's like 5 or 6 numbers, I can probably very quickly just go, oh, look, 5 is the biggest. Not a big deal, right? Why do I need this function? Okay, if it's 5 numbers or 20 numbers, what if it's 100,000 numbers and you want to find the biggest one, right? A little more challenging, right? So that's why these exist. And these are also considered pretty important values. What is the smallest one? What is the biggest one? Why? That kind of thing. The syntax for using them, by the way, is just very simply you use the keyword followed by a set of parentheses. What goes inside the parentheses is the column that you're looking at. Now, I want you to understand that our brain tells us that when we do max and min, that they apply strictly to numbers. Why? Because, well, numbers have a value and they're ordered, right? So normally we would, okay, so we might like minimize a column of like what's our smallest sales or sale item, or what item do we have the most inventory of, and it's a number. But it can also apply to alphanumeric characters, by the way, and dates and other objects too, when it comes down to it, not to confuse things. The max function is very similar, right? That you just use the max keyword instead and you apply it to a column. They have a little bit of a demo database here where they're looking at some products. There's IDs, a name, supplier ID, category ID, what looks like a description, and then a price, right? All right. So we can do a min, and then notice it's being aliased as smallest price. And it's really common when you run a function, you get output and it creates a new column of information. It makes a lot of sense to alias it, because otherwise what's going to appear in the column header? And you know what? Let's answer that question by kind of doing it. All right. So I'll run the regular query, right? And you can see the smallest price is 250. I'd have to go back and verify that, but I believe it, right? But what would happen if I omitted this and then ran the query, right? And these are goofy little things that you should try. Well, then it displays the name of the function. Okay. In this case, the function name and the column, I mean, it sort of makes sense. You have to admit, though, it's not user friendly, right? So doing an alias on it does make a lot of sense. right? So that's the alias. You can do the same thing with max, and I trust that that works. Okay, so those are max and min functions, very commonly used. Um, you know, who's the tallest? Who's the smallest? Who's the widest? Who's the thinnest? Whatever. Bad examples, but yeah, I think you get the concept. All right. The next topic that we're going to look at are these three functions, also very commonly used: count, sum, and average. And it just so happens to be the next topic here at W3 Schools in the order of links. All right. Like the max and the min function, these require that you use the keyword followed by a set of parentheses, and then what we call the arguments or the parameters for the function go inside the parentheses, right? And those that know how to program understand that when you run a function or a method, the stuff inside the parentheses is called an argument or a parameter that's being acted upon by the function. It's basically the thing that we're feeding to the function for it to do something with, right? Right. One function that's used a lot in database work is like, okay, well, how many students do we have? Right. We were just looking at a student database. Well, I don't know. I guess I could run a query and then count the output. Well, there's a function for that. Right? That's the point. So particularly with large data sets, you can run the count function. Now, from a practical standpoint, I'm just going to go back to MySQL Workbench here for a second. If I was running a query that just dumps the whole table, in some cases, it'll tell you how many rows it returns. So if you look down here at the output, 5 rows returned. So if I returned the student table and it had 1,554 students in it, it would tell me it returned 1,554 rows. So how does the count function work? It runs a query and then looks at how many rows there are. That's how it works. Very common sense. I assume that's how it works. But we're counting how many things. Now, what if, this is a thing to ask yourself, what if you're dealing with null data? Does that get counted? Deeper question. Yeah, okay. Yeah. And you'll have to run that one to figure it out, by the way. All right. Another function is the average function. Now, the average, and when we say average as a function, we refer to the mean, not the median or the mode, just the mean. The mean is, let's say you have 5 values, you add them together, you divide by 5, and that resulting answer is the mean, what we call the average. All right. That one is very, very useful. Like, so for example, if I say, hey, what's the average selling price of a guitar in my guitar shop database? I can run that query and say, oh, it's $349 or something like that. We also have the function called sum, and sum will add things together. So if I have run a query that, let's say, grabs all the sales figure for a day, I can run the sum function over it and then tell you what our total was for today. Right. So that's a very useful one also. They have the sample database here as examples and have some very basic queries set up. If you guys want to play with those, feel free. We will play with them soon. And there's your answer, if you're wondering. Right? I knew it was at the bottom, which is why I kind of reserved it. But reading is important, right? Read through all the examples and understand them. And I would encourage you to do all the try it yourself things. And then you want to try to sum something other than quantity, try it. Can you sum a name? I don't know. Try it and see what happens. All right, back over to the course shell here and on to our next lecture topic. And these are the commands that actually give us what we call the summary queries, basically. So I'm going to bring up this link here, which is the group by command. And all right, let's read about it first. All right, so it says, the group by statement groups rows that have the same values into summary rows, like find the number of customers in each country. Okay. We often use it with aggregate functions. So this is why we're learning these together, right? So for example, I might want to do a count, or I might want to find the maximum in or sum first, and then do a group by statement, right? So often used with what we call aggregate functions. So all of these functions that we learned are called aggregate functions because to aggregate means to gather together information. And the way all of those functions work is they look at all the data in a column and they figure out the max, the min, the count, the sum, or the average. So it's aggregating the information. And it groups the result set by one or more columns. So I could, for example, I could group by the number of customers. That sounds like a count of the customers in each country. And I could maybe even add a grouping for a city. So I could break it down by city if I wanted to as well, right? Let's take a look at the syntax here, the general form of it. So we pick the columns, the table, the condition by which we're choosing, and then we're grouping them by. So there's a command called group by. And what is the grouping mechanism? Are we grouping it by country? Are we grouping it by the size of the sale, et cetera? Let's just assume country. And then, of course, we can still order it. And often when you're doing grouping, ordering is kind of a given, right? Because you want things to be organized. I don't know if you guys remember the customer database here, right? We got people from all over the world buying products. So let's try this group by. I'll bring it up in the editor here. So the first thing that we're going to do is we're going to basically look at the customer ID column. Why? Because every customer that we have has an ID, whether or not they've made a sale, or an order, okay, whatever. So we're going to count all of our customer IDs, and we're also going to select the country table. So we're doing a count and the country columns from the customers table, and then we're grouping by country. There's no ordering going on. So let's see what that output looks like. All right, so if we scroll down here, you'll notice that it shows us the count. Yeah, not a very friendly username, by the way, right? But not that bad, right? So we have 3 in Argentina, 3 or 2 in Austria, et cetera, et cetera, et cetera, right? This is running one function and then doing basically a sheer count of how many customers we have from that country. All right, so that's the group by example. Here's another one, same thing, but notice that now we're grouping, right, by which country has the most customers, right? And that's, right, group by, and then order by, and notice the use of the count statement here. So I can use the output of my function as a value to sort by. So, all right, let's see which country has the most. All right, so apparently it's the US, then Germany, then France, then Brazil, and then we move on down from there. Right. Very typical type of query, by the way. All right. Next, we're going to take a look here at the orders table, right, in the Northwind sample database. We're adding and a selection from the shippers database. Now we're looking across 2 tables. So I want you to be mindful of that. And we're grouping now with a join happening at the same time. So we're going to select the shipper name from the shippers table. We're going to count the order IDs from the order table, alias it, right? So just those 2, it's really just 2 columns. So the shipper name and the order ID is a count. And then we're going to join the shipper table on the shipper ID. So we're only going to count the orders if the shipper, the order got shipped, basically. And then we're going to group it by shipper name. So let's just run that query quick and see the output. But this one's a little bit more complex, at least conceptually in concept, but we are now able to query across multiple tables, run a function, group it, and combine that into a meaningful output. So like I can see now which of these services we're shipping more stuff through. And that is useful. Like who's sending most of our orders? Okay, I guess it's federal shipping, or whatever that is. Imaginary shipping company. All right. The next topic that we have here is the having statement. So let's just copy that link. And I'm not sure if that's nearby in W3 schools right now or not, because I didn't even look. I guess it was the next one because they go together, right? All right. So this is why it was added. Having is basically works like the keyword where, but where cannot be used with those aggregate functions for whatever reason. This is something behind it in the code. So we have the ability then to use the having clause in its place. So take a look at the example here. Select a column from a table where there's a condition and we're grouping it. And then the having really becomes the condition for the grouping. So if you think about this, right, when we run all this is going to create an output, but I want to qualify the output with another condition. So I can't say where again. So instead, I'm saying having. And then I can do my ordering or grouping or whatever again as well. Right. Back to our customer database here. And here's an example. So in this example, they're going to look at the count of the customer IDs from the countries like we did before. We're going to group by country, but only, right? So this is kind of like a where it's having a count that's greater than 5. So if we only have a customer or two in that country, whatever. We got more than 5, all right, I'm interested. All right, so it's got to be 6 or above. Let's run that, see it work. Here's the run. And you'll see that all of these have at least 6 customers. All right. Here's another example, right? Where this is kind of a weird one. I don't know why you would do that, but having a customer ID greater than, right? So we can run that, and then we can order by the count. So I'm just going to run it just so you can see it, right? And you guys, whenever you read this stuff, you really should do the same. Right? So is there a count greater than 5? Yes. Once again, we're ordering by count descending. So now it's like filtered and sorted in a way that makes sense to us to look at. We still want to see the biggest ones on top. Right. Another example here, this is the orders table, employees table, and a few more examples, right? And they get pretty verbose with their examples. Here's an example that joins tables, by the way. And I'm not going to like run this one, just so you know. But I just want to have you look at the structure of it, right? Then also notice here where they start to get kind of particular. So they can join a table, group by last name and looking for a certain count, or we can do an inner join on very specific pieces of information where we're looking for very particular people. And notice we only have one where statement here, but we have an or because we're looking for Devolio and Fuller, anybody with those names. And then there's another having statement, which helps to qualify it only if it's over 25. Right. There's one other piece of reference material here that takes us over to this other website, and I'm going to kind of bring this up. I'm going to bring this up in Brave also. Hopefully that'll block some of the pop-ups that this site's known for. There's also an additional clause that we learn about that kind of goes with this grouping and summary queries, by the way, and that is this command called rollup. And what they do here in order to explain how a rollup works is on this website, they actually walk you through the process of telling you how the grouping works first, right? So they create a table, they select, information, they group by, they show you the information in the table so you can see it, right? And we've already been tinkering with the group by statement. And I want to show you kind of like a different approach to it. Notice that they are still using a summary query or a aggregate function, excuse me, here, right? So that's very, very common when you're doing grouping. I don't want to answer that question right now. Thank you. All right. And they show you the result, right? So we start with this data set, and then they do a very simple grouping by product line after they summarize. And I want you to notice that they can take all the classic cars and then total all the values together. So this is like one of those reasons why this is particularly useful, right? Because you have people that want to see okay, well, we have these categories of classic cars. These are the sales. Can you give me a summary of the sales for that group? Right. And I think that that's a really nice example, by the way, right? So they just all the major groups and the sum of the order value for all the groups. So you can see like which areas, more popular, generating more revenue. Here's a nice little example where they're summing the order values for basically all the orders, right? So the total order value of all the orders together. All right. Now here's a command we didn't learn about yet, but it is possible. And I'm because we haven't learned this technique doesn't mean that it's not a valid one to learn, but we can actually do this what we call a union, where we're taking two queries, kind of grouping them together and joining the output of them. And this is I'll call this a little bit more advanced skilled, and this is not the focus of our lecture right now, but they're basically taking this query, which is grouping by product line, and this one, which is summarizing the total order value and adding it all together, and then also giving us a value for the stuff that's in the null category that we couldn't see before. And they kind of go on that for a while, but they lead this to an output, right? And it kind of points out the fact that a couple of different things, right? It says the query can generate the total order by product lines, also the grand total. However, it has two problems. The query is quite lengthy, and the performance of the query might not be good since the database has no internally, blah, blah, blah. It has to do two queries, join them together, and then generate new results. It's resource intensive. So what they created to kind of fix that issue, instead of using a union command, is they have this command, which means with roll up. So this is the general syntax here, but if you put it into an example, now they're selecting the product line, the sum of the order value from the sales table, and they're doing a roll up. And what that does is it automatically groups them with the description. So it kind of like wraps it all together, is kind of a good way to put it. So it says the roll-up clause generates not only the subtotals, but also the grand total of the order values, right? So this is, it's kind of like if you guys have used the summary tool in Excel, that has one of those kind of like subtotals and summary columns. It's very, very similar. It kind of does automatically what a lot of people do when they write queries anyhow, rather than write a big, lengthy, complex one with joins and stuff. You can do the roll-up, and it kind of handles all of that for you, right? It does assume a few things. So if you guys want to read up on this, like as you put the stuff in there, it assumes you want to follow that order, and so that becomes pretty important, right? So group by, right, columns with roll up will give you summary information, and that's kind of the overview of all of our lecture materials here, folks. And I think what we should do at this point is let's take a break. We've been going for a really long time without a break. Then we'll come back and we'll work on the homework. It's about 6:43. Let's call it 6:44. Come back at 6:49. So I'll see you guys in 5. Welcome, everybody. Tonight we're going to be working on the exercises for Unit 5, which focuses on summary queries and aggregate functions. And I do have the instruction set pulled up here in a document. And it looks like right off the bat, it says that we're going to be working on the classic models MySQL database. So I'm going to take us over to MySQL Workbench here. I'm going to close all my open tabs right now and just see if I have that database loaded up. Now, I want you to be mindful of the fact that if you do not have this database, there's somewhere that you can get it, right? So, and I always run into this issue, right? Because frankly, you get older, forget a little bit. It's like, did I have you guys install this one yet? Or is this just left over from last fall? Kind of like that. And my gut instinct is telling me that this is left over from last fall. So I do want to show you where you can find it in the course shell. So if you go to the course resources, right, you'll notice that there's a SQL file here for the classic models database, right? And you can download that file. And then you can use MySQL Workbench to open it and run it. And I'm just going to show you what's inside of it. And I'm just going to bring this up in Notepad++ here just because it's handy, right? A bunch of like cryptic commands, but basically creates a database. It attaches to the database, and then it starts building all the tables and then inserting into them all the information. And then, for the sake of just demonstrating it, what I'm going to do is I'm going to run the script just to show you. And it also ensures that I'm starting from a clean slate. And so I see right now that I do have that database here. And so the first thing I'm going to do is, I guess I'll zoom in on my code so you guys can read it, but I'm going to say use classic models. All right, we'll run that. So I just want to make sure I'm attached to it. And then I'm just going to issue the drop database classic models. And then I'm going to run that command. And then you see my schema table already updated. So it's gone. Goodbye. Right. And I'm just going to remove. Well, you know what? I'm going to remove the first command because that one I'm probably going to use. Okay. So now I'm going to go to the open SQL script off of the file menu. And then I'm going to find that file that I just downloaded, which is this one here. I'm just going to open it. And you can see this contains a little bit of data, right? Because this is all the information that builds the database, including the data for the tables. And the reason I'm scrolling through it is I want you to notice that this has a lot more data in it than the stuff that we're used to working with, right? So it's kind of like a real database because I'm like up to like 1,000 lines of scrolling now, and I'm still scrolling, and my thing is like up here, so I got a long way to go, right? But all told, this is a pretty large file. It's almost 8,000 lines long, right? And it's got a lot of stuff in there, but it's got a lot of things built in to help build the database. So we're just going to run it. So I'm going to run the entire file, right? And you can see it did a whole bunch of commands, probably some successes, some failures, some warnings. But overall, when I hit the refresh button in my schema table, I do see the classic models database is now present and all the tables. And if I click on one of the tables, I can see the data. And you can see how this is a much, much richer set of information than some of the other databases that we've been working with. And this is the one that we are running for this exercise. All right. I can close these tabs now. Now that this query is run, it's done its work. It's created the database, put in all the information. I am going to execute this command here, the use statement, just so I know that all my future commands will be attached, right? All right, now back over to the instruction set and let's see what our tasks are. All right. All right, I'm going to zoom in ever so slightly here, not too much. All right. It says create a query with a count of all the customers grouped by country. Hey, that sounds pretty darn familiar because we were just doing that. And what I'd like to do here, and I'm kind of pulling my file folders over, is I'm also at this moment pulling up my solution files because I forgot to do that in advance. Normally I'm really good about it, but hey, it happens. And now, of course, I see I have two different versions of the same file. That's not good. All right, so let's just start with that first command. And we already ran our use statement. And I'll have you think back to the examples that we were just doing. You know, most typically when we're running a summary query, we are, going to do this. Now, I guess we should ask this question is, okay, first of all, I'm just like starting to type code. I don't even know my database yet. I haven't even looked at it too much. But it says create a query with the count of all the customers grouped by country. We can assume it's in the customers table, but I haven't looked at the data in the customers table. Well, I sort of did, I guess. And I certainly didn't examine the columns and what information. And if we were to count the customers in the customer table, what would be the most logical field to count on? Well, here's some general thinking on this. Because every customer has to have a customer number, and that's a primary key. So that means it can't be null, right? When it's a primary key. That becomes the go-to for counting how many things are in this table, right? All right, so let's do that. So let's count. We're using the count function, parentheses. Then inside the parentheses, what field are we looking at? And we're looking at customer number. And I'm noticing that it's spelled with the lowercase c, customer number, capital M. Right? I think this would look ugly as an output, so I'm going to create an alias, so you can say as, and last time this is what I did. I said number of customers. Maybe that's not all that user friendly either, but that's what I did. Right? You can make it say whatever. All right. We're also looking at the country column though, like what country they come from. So we're selecting the count from the customer number and then the country as well at the same time. This is coming from the customers table. We know that we want to group by country because they told us to, right? Yeah, they did. And then do we care what the ordering is? I'm going to say we can just run it and it doesn't really matter, but we can kind of simulate some of the stuff we did in the examples earlier. So let's try that. So I'm going to just run it like this for right now. And then I'll add a order by statement just to give it, some logic or structure. So here comes the run, right? And so you can see the number of customers in these countries, right? Some have a lot, some have barely any. All right. And then if I wanted to, I could order by, well, what could I order by? Well, you could order by a lot of different things, but remember the examples that we did. How about the number of customers in each country descending? So the biggest numbers are at the top. So I'm going to say the count function again. We're going to do the same thing. We're counting the customer, the number of them basically. And then we're sorting in descending order. So let's run it now. And now we have an output that looks a lot like our examples over at W3 Schools that we were looking at just a little while ago. And I think this is a useful output. I think that, because typically, think about this. If you were a manager, do you want to see the countries with the least customers or you want to see the customers with the most or the country with the most? Exactly. Well, it depends on what your objective is a good argument as well. All right. Now, if it's helpful, and I'm just saying, you could drop in comments if you want. That's on you if you want to do that or not. That's a personal decision. But I do find that I often like to put comments in my SQL file so I can keep track of which one is which. All right. With the next one, it says create a query with a count of each of the product lines. Okay. Without knowing a lot about this database, once again, I have to do a little bit of data investigation here, but they're applying a product line, and I'm noticing there's a product line table. You guys picking up on that? And they also have a products table. So, all right, I want to take a look at this first. So, first I'm going to look at product lines. I'm just going to run the select all query thing and go, okay, they have classic, cars, motorcycles, planes. Okay, this looks familiar, right? Classic cars. All right. Then I'm also going to look at the products table. So here's the products output. And then I see product codes. That looks like a SKU or something. Product name. Well, the product line is here too. So I'm just thinking out loud, I probably don't need to look at the product line table for my query. I can probably get everything I need from the products table. Right. Whereas if the product line was like an ID and it was a foreign key setup, right, and it was linked and it didn't say what the product line is here in plain text, I wouldn't be able to do it. So that's one of the reasons I'm taking a look at my information. So it says create a query with a count of each of the product lines. All right, so I'm going to start with a select, and I am going to do a count again. That's going to be the function we're using. And I know that the products table has a product line column, so that's what I'm counting. Okay, so we're going to count the product line. And if you wish, and this I would say is optional, you might say number of product lines or something like that. Right. We also want to actually pull that column in. We don't just want to count it, but we want to pull the name in from it. So we're going to run, we're going to include the column name in the output. This is all coming from which table? The products table. Are we joining tables or anything? Nope, not in this case. We didn't need to. And then we will group these by product line. Why? Because we were told to. All right. And once again, should we order these by the count of which product line is bigger or more, has more, basically? That's what I'm going to do. Right? And I would say that part's probably optional too, but I think it's a good thing to put in there because that's a useful type of output. So let's run this one, take a look at the output. And that's what I'm getting for an output. So I have 38 classic cars, 24 vintage cars. Not sure what the difference between those categories are. Motorcycles, planes, trains, and automobiles, folks, basically, is what we have here. Okay, so hopefully that worked for everybody. Everybody okay? Okay. As I put one more piece of cheese in my mouth. All right, let's move on to number 3. So number 3, and I should bring up the document ever so briefly here. There we are. So number 3 says, create a query that calculates the average payment amount by customer having an average payment greater than 10,000. Okay, that's a little bit taller order. There's a lot more going on here, right? So we need we have to calculate the average. Okay, we know the function for that. And then we're also going to qualify it by, remember, not the second where statement, but a having statement where the payment's greater than $10,000. And I think first we need to look at some of these tables and columns first to figure out where we're going to pull this from. Okay, so they mention customers, they mention payments. All right. And so I'm thinking that gives us a couple of tables to look at. Well, first of all, we have the customer table, right? And I'm just going to run that again, right? So we can figure out which customer, right? I think that's important. And then this is all demographic data, though. If you look at it, right, they have a credit limit, right? So like they don't want to give credit to just anybody, or or certain credit amounts. But there's nothing in here about payments, right? Not at all. All right. So that's first thing. Is there a table that might have information about payments? Okay, well, payments has information about payments, I'm guessing, because it's called payments. So let's run that query and take a look inside. And I'm noticing that it shows the customer number, not the customer name, the check number, the payment date, and the amount. So some customers have multiple payments, right? And some might not. I'm not really sure. But these are pretty hefty payments because they're buying big ticket items. So those are very large payments for sure. Right. So let's take what we know now and try to figure out the situation. Now, here's the question you ask yourself. Do we need to join any information to get this information? And my gut feeling on this is no, because it says create a query that calculates the average payment amount by customer having an average payment greater than $10,000. And you notice the output, they're only looking at the customer number. So in other words, I can look at, customer number 114, find all of his payments over $10,000. 3 of them are over. So you see that's what we're looking for. All right. So let's build that query then. Let's start with select customer number. All right. Because that will basically help us identify the payment. All right. Couple things that are happening here. We want to average. What is it that we're averaging? Well, let's go to the payment thing again. We're going to average the amount to the payment. Okay, so let's do that. And what are we dropping in here? The amount. Okay. I'm keeping in mind that in the back of my head, this is all coming from the payments table. So I better put that in right now. So from which table? Payments. Okay. Couple of things. Let me backtrack here for a moment. I'm thinking, you know what? This is a weird function. It might not really resonate with some people. So you might want to like output it as average payment, right? And mind you, that should have quotes around it. I guess if I look at the document here, they're doing AVG underscore payment. So okay, maybe I'll follow that. Let's follow what's shown, because that's probably what you guys would do, right? Underscore something like that. Now, because this is one singular word, don't need to put quotes around it, by the way. All right. We're going to, group these by the customer number, something we were doing before. So customer number. And then we also only are interested where the average amount is over 10,000. So instead of a where, again, we're going to use a having, because you can't use where with those aggregate functions. So I'm going to say where the average of the amount is greater than 10,000. No commas in the number, right? It's an integer. And then let's do a little ordering in here. So let's order it by, how about that alias column we create? Can I order it by that new column? Yes, you can. All right, I'm going to go ahead and run this. And let's take a look at the output, because I think the output of this is kind of interesting. So I'm going to run it. And here's, gosh, this is great. It worked just fine, right? Except I don't like the way the money was output. Why? This is money. Why is it like giving me 0, 0, 0, 0, 0, right? Or even, right, it doesn't even round to two decimal places to make it clean for money. Like this one's like a 666 repeating and whatever. Is there anything we can do about that? And you know what? There is. There's another function, by the way, that I'm going to kind of like random here lecture you on. That's called the round by function. And what I'm going to do is I'm going to take that command and I'm going to wrap it around the average function. So I'm putting parentheses around it. So this function and its parameter now become a parameter for this function, but the round function has two parameters it requires. What are you averaging, or what are you rounding, and comma, to how many decimal places? Well, we want two. So we're going to round this to 2 decimal places. All right, let me go ahead and run this and take a look at the change in the output and how that is something that we're more comfortable seeing. Now, more importantly, when it does the rounding, right, what is the rounding criteria? If there's extra digits, does it just cut it off? No, it's not how it works, right? If the value in the digit that follows the second digit here is 5 or above, it rounds this number up. If it's below, it keeps it the same. Just so you guys are aware. That's what rounding is typically. So we're kind of throwing in the round function here. So I think that's pretty handy one. And that's maybe one I want to add to my lecture materials for the future. Pretty simple one, but useful, right? And not very hard to use. Okay. I'm going to pause the video here for just a sec. All right, well, let's take a look at some possible solutions here for number 4 and 5. And I'll just read these really quick. And it says, create a query, excuse me, got cheese in my mouth, that totals all the payment amounts by customer. All right. All the payment amounts by customer. So in other words, instead of looking at the count and then coming up with an average, we are looking at what was the total payments that particular customer made. It's a little bit different logic to build this one. All right. So let's figure out first where the information come from. And I think we already know, because we've been working with the data now for a little bit. And we know that the payments table has the customer number and the amounts. And when I look at the Word doc, the output shows customer number and total payments. If I were to ramp it up, we could join a table and add a customer name in here if you wished, but I'm not sure that that's what is being asked for, because that's certainly not the sample output. So that really simplifies how we're going to write the query. All right, so here we're going to say select, and let's think here. First of all, what table are we pulling this from? We are going to pull it from the payments table again. Okay, so that helps to narrow things down, and I can look at the fields, right? So customer number, check number, payment date, and amount. Customer number is one of the things that we're grouping the amounts by. So we just want to pull that column in. Right, so we're just going to pull the customer numbers. And then we want to take all of their payment amounts, which the column is called amount. Just want to do a sum. So we're going to say sum amount. We're going to sum that amount, and we'll alias it as total payments. Or if you like the underscore approach, you find that a little more readable, let's do that. Okay. Coming from the payments table. And then how are we grouping this? We're going to group this by the customer number, right? So we're not going to have a separate listing of each transaction. It's going to be a total associated with one customer number. That's the grouping. Semicolon, end the statement. Let's run it. And there you go. And then if you compare this to the example, all right, any issue with this? Now, why did this one round really nicely to 2 decimal places? It's a good question, right? Well, if you look at the original data, right, it's all 2 decimal places. If I add numbers that have the same number of decimal places, the output is the same number of decimal places. It's not going to add another column of decimal places. So that's the why. Right, that was number 4. With a few minutes left here, let's look at number 5. Number 5 says, create a query that displays total number of orders and their sum, and they have an example, and you notice it's just 1 row of information. So I got to count the order table orders, right? Total number of orders and the summary. Is that all going to be from one table? All right. Okay. So these are the questions you ask. So if I look at the orders table, okay, well, this is problematic because this doesn't even have the prices, right? So I mean, but it has the orders. I know how many orders we have total by looking at this table, right? Okay. What about if I look at the order details table, where that takes the order number? Okay, so this gets even weirder, right? So this shows the price each, not the total price. All right. You guys see some challenges on this one? This is a little bit different one, and we can have some lively conversations about it if you wish. But what I'm going to do is I'm going to show you my technique for doing this. Now, we've already identified the informations in 2 tables, correct? And so we want to join. Which tables do we want to join? Orders and order details, right? All right, so let's come back to our master query file here, and let's start building this. So the first thing I want to do is, all right, well, I want to select, and I got some stuff to select, I know that. And then which table is the primary table I'm pulling from? And I'm probably going to say the orders table, I think, is the primary table. And I'm going to alias that as O, by the way. Okay. And then if I want to interjoin with another table, that's going to be the order details table, because that's where the other information resides, and that one does not have capital letters in it. And then I'm going to alias that one as OD. And notice how it's giving me an error. What's the error in my syntax, folks? How do I fix it? Oh, well, what it's telling me, if I hover, hey, it's like, hey, you didn't type anything up here, so this doesn't work. That's what it's telling me. But the reason I'm doing the from and the join first is so that I can keep in my head which tables I'm working with, so I don't lose my place. That's how I do it. very often. So the two pieces of information are the total number of orders and the sum of all the price totals. So the one's a count, right? So what am I counting? I'm going to take the order details table and pull the order number, and then that's a capital N on that one. So order details, the order number. So I'm counting those. That tell me the total orders. Okay, so that makes sense, right? And then I'm going to alias that as total num orders, if you wish. Then I need the other piece of information is to take the information in the price column, right? And then total that or summarize it or get a sum. So I'm going to use the sum function. That's also coming from the order details table for price each. And then I'm going to alias that as price total. I forget how they had it in the document. Price total is what it is. Price total. Now, there's an additional piece of information that we're not thinking about here, and that is why am I including two tables? Well, there was a reason why we included it, because it has to match up. The order number in the order details table has to match up with an actual order in the orders table. So the criteria then becomes the order number in the orders table equals the order details in the order number column in the other table, right? So it's only doing it if we actually got an order and made a sale. That's the point. All right, let's run this as is and see what the output is, and then let's talk about what it means. All right, and I see that I have the same output amounts, so I think it worked okay. Right. Couple of alternative approaches, right? And I think we've talked about this, is that inner join is one of those statements that you can type in, or you can actually also do this, right? That's also an inner join, and I think we talked about that before. But let's use the inner join terminology here just to make ourselves comfortable. Now, I noticed an anomaly, and I wanted to really kind of like scream about it a little bit, right? Because when I looked at the orders detail table, it is looking at the price each, right? But do you guys notice how many items were actually ordered? So really it's 30 times 136. And then you come down to this conclusion. Is there a way I can do math and calculate that total? And the answer is yes. We'll work our way up to that. But if your brain even thought to ask that question by looking at this information, then I'm not going to say there's hope for you. I'm going to say that that's great. You know, that you're recognizing that fact, because really the order total is really should be a lot higher. You guys feel what I mean by that, right? Yeah, totally. All right. But if this was the answer that you gave, I'm totally okay with it. And you know, we didn't learn how to do math in here yet, really. I mean, we've done these aggregate functions of like count, sum, and average, which is cool and definitely useful. So let's cap it here. So this video will end here. Make sure you save your SQL file and submit your homework.